Hey, all right. And there we are. It's me, John Park, and welcome to John Park's Workshop. How are you doing? How's everyone doing? I was out of town, and now I'm back, so hello, and thanks for having me. I'm just checking my camera settings here because things got extra zoomed in while I was away. I don't understand how these computers do these things even when you turn them off, but I'm going to fix it, and there we go. Hi! That's a little better. So hopefully you are all here and ready for action. I am just checking some audio levels too, because I don't want to peek out, but it looks like at least the song I was playing earlier had some decent levels. And good. All right. We're all clear. Thanks, C. Grover, in the chat. If you're joining us in Twitch or in Facebook, most of the conversation is happening over in Discord. So check it out. Also, YouTube chat. So come on by, would you? So let's get started. Let me check my notes. By the way, if my notes are correct, this is my 97th episode of John Park's Workshop. So that means we're headed towards 100. Maybe we should do something special for that one. Send me your suggestions. What are we going to do for the 100th episode? Something special. We could have a cake. We could make some cake. All right. So let's see. The first thing I wanted to do, news, a slight news segment. I've got this to show, which is my ARDUBOY, my original Kickstarter edition one, the red one here, just got fixed. I sent that back to Kevin Bates, and he was able to swap the screen out. The little OLED screen had gone super, super dim, all on its own, I promise, because sometimes these can actually be affected by sunlight. But mine was not in the sun, and yet it became dim. Now it's all fixed, and now I can play some Circuit Dude again on my ARDUBOY. If you're not familiar with ARDUBOY, it's a platform, and it uses Arduino to program games on this lovely little handheld. Super tiny credit card sized device, and we sell them in the store, so go check them out. So that's my news. Now let's move on to this. We've got a jobs board, and in our jobs board there are jobs, and there's also a position or a place to enter your info if you're looking for jobs. And I wanted to point out some that I saw, which was, what's this? Animal Ear Emulation Arduino IDE Python in Twin Blue Chimera, Rock Island, Illinois. What is that? Looking for a coder to write a sketch for a microcontroller emulates live ear motion for costumes designed with servo systems. Whoa, that looks cool. Check that out, huh? So that's just an example of the kind of interesting stuff you can find on the jobs board. So jobs.adafruit.com, that'll be interesting to see what comes of that. I'm interested. So what else have we got? I mentioned, thank you, George. Did George do it? Mr. Certainly, thank you, Mr. Certainly, for placing a link in the Discord chat to the ARDUBOY. And also I'll mention ARDUBOY can be emulated on the PyGamer using the Arcada. It's not emulated, actually, it's compiled for it. So you can run ARDUBOY games on the PyGamer and on the PyBadge. So if you develop for one, you can develop for all. Now I want to mention a little coupon code that we've got today, and that is controller. So if you enter in controller when you get to the Adafruit store and you go to checkout, there's a little coupon code box. Type in controller and you're going to get 10% off. And that's good on all the stuff, all the things you can buy, such as an ARDUBOY or a PyGamer. I think we have some of the AdaBox 12 non-subscription versions left, and I don't know what the difference is between the subscription and the non-subscription. Sometimes it's a LiPo battery or not, but anyway, that is currently the best way to get yourself a PyGamer that I know of, because I think we're out of stock on PyGamers. But if you go to the store and check out the AdaBox 12, those are available now in the store, and you can get 10% off. You can't use it on software or gift certificates or subscriptions, but you can on stuff. And speaking of stuff, I have a product of the week in mind, and I also have a little mini build that I built to show it off. this is my product of the week, and it is our 75mm long slide potentiometers. These are also known as faders. You can use it as a variable resistor, you can use it as a voltage divider, and you can read the voltage divider output on pretty much any microcontroller. For my little demo, I'm using a feather, but you can basically plug these in. You'll want to get voltage and ground on 2 of the pins, and then there's a wiper pin, I think it's pin 2, that you can use to read that varying voltage, which is really useful for all kinds of stuff. These are these nice long ones. I'll mention, actually, let's check these out here back in my browser. There's this one. This is the 75mm long one. And coincidentally, I just built this little demo, and lo and behold, Late Ada has just added some 45mm, some little shorter ones that have a plastic cap on them. These longer ones have a little rubber cap, or a nub, or a nubbin, whatever you want to call it. And so for a little demo, what I decided to do was put together a little 5-fader box, and let me run over here and demo it for you. I'm just using it to control a NeoPixel strip right now. So let me slide this over to the side. What you can see here is I've got one of my faders controlling how many of the NeoPixels on this little 8 NeoPixel strip are lit up. You can see that. Nice smooth control. And then this is an RGBW NeoPixel strip, so it means it's each of these elements has a red, green, blue, and white. So that's what I'm using the rest of these 4 faders for. So you can see here if I swap up red, green, blue, here's white. This is actually the warm white. And if I give you something to reflect off, you'll probably see that better in the camera. So now we can mix those. So you can bring in like a cyan with the green and the blue. You get a magenta with the blue and the red. Some oranges, yellows, and you can always add to it with this other. And I can slide those up and down. So if you look inside of here, you'll see I have these 5 potentiometers that I mounted with some screws to a little laser cut wood case I built. Mounting these is tricky. Or rather building something to mount them on nicely. You could use cardboard, cut them out sort of carefully, and either screw them through or maybe use some hot glue to attach. But that's always the sort of biggest issue with using these faders is you kind of want them stable and affixed to something. So I built this little laser cut top, and then this bottom here I've got a feather and a feather wing, which is the terminal or proto, what do we call this one, the screw proto terminal feather wing, something like that, so that I could screw in these wiring from my potentiometers to read those on analog ports, as well as my output to the NeoPixels. So that is my little pick of the day for the product, which is those 75mm long slide pots or faders. Check them out. So let's see, where'd I go? Hey, there I am. Yeah, Andy Calloway says, cool color mixer. Thank you. Actually, one other thing I'll mention about this is with it hooked up to a computer, I wrote that little sketch in CircuitPython, and I can output the color values as I am pushing the sliders around, which is really nice because it's difficult often to get the exact color you want out of some RGB LEDs through trial and error of changing numbers. And instead here we can mix red, green, blue, and when we like a color we can just read those values, and you could probably have it also spit out hex values or hue saturation value. I have it spitting out RGB. But it's really useful for coming up with colors that you like. It's just to get in there and do it by hand. That's a lot easier than trying to plug in numbers and update. So yeah, cool color mixer for sure. All right, so let's see. I think this brings us to That's right, it is the Make Code Minute. And so for the Make Code Minute today, what I wanted to show is how you can set up a debugging control in a Make Code sketch that you're building for, in this case, Circuit Playground Express. So if you look at my code here, what you're going to see is I have on start, I create a variable called debug, and I set it to true with this Boolean. And then I set up the switch on the Circuit Playground Express, so when I move it left, debug is set to true. When I move it right, debug is set to false. And then the way I'm using this is when you're testing code, let's say you want to lower the volume and stop all the blinking lights because those are bugging you, and you know you're going to use them in the end, but you want to keep the code in there, just not always bugging you. Well, that's how this debug works. If I check out this forever loop, it says if debug is false, then we're going to show the animation. And then when I press the button, if debug is false, yes, if debug is false, the volume is going to be really loud, set to 255. When the debug is on, I'm going to set the volume down really low to 8, and then I play a sound. So if I bring my actual Circuit Playground Express in, you'll hear, okay, first of all, you see there's no blinking lights. I'm going to flip the switch. This takes it out of debug mode, and now when I press the button, I get a loud sound. When I go to debug mode, I'm not seeing all those blinking lights, and I get a much quieter beep. So that is how you can set up a debug mode inside of Make Code for your Circuit Playground Express. All right. So I find that really, really useful, and that's a nice way to have it just in one place. In this case, it's really convenient that we have a slide switch, but you can also just do this in your code. At the very top of your code, you can set a debug in the on start, and then you can flip that on and off yourself while you're working, so that whole huge sections of your code, such as when you're working with Make Code Arcade, if you have a whole intro and an intro animation, you can just cut to the chase and get to the part you want. And pretty much for any code, it can be on Maker Make Code or Circuit Playground Express Make Code. Having a debug allows you to jump in to the parts that you want. And you can set up multiple sort of levels of debug if you want, but just getting started with it, keep it simple and give yourself an on-off. Am I debugging or am I not debugging? So that's your tip there for the Make Code Minute. And now let's see, we're going to take a look at something here in the game of the week. And so I'm going to switch over to my Make Code session again, and let me swap over to a different tab. So my Make Code Arcade pick of the week is Snowy Slopes by Eigenjoy. So this started out as a forum post here in the forum.makecode.com, and it includes a link to the game itself. So I'm going to show it off first. So let's go to a full screen mode here on the game and hit play. And it's a downhill skiing game. So you can see it'll start up. You're not going to hear the sounds because I don't have those patched through, but here it's playing, and now I can use the left and right arrow keys, and you can see he'll turn, and you can also accelerate by tapping the key a few times. And check this out. I just hit a snowman and I turned into a snowman, and I absolutely love that. I think if I crash into a tree, I'll lose my cool snowman costume. Let's try to do that. Oh, I doubled up. Now no trees are going to show up. I should have set this to increase the tree output. Oh, I just passed level 1. Oh, there, I hit a tree and I lost my costume, also slowed way down. So let's take a look at how that part is done, because I thought that was a really clever technique. And the way it's being done here is actually in the animation setup. So let's check out this function here called setup animations, and I'll zoom in so you can see that a little better. And this is actually one function that's being used to set up all the animations that are used for the different sprites in the game. And you can see here there's an animation that's called the skier idle and skier left and skier right, and there are each these cute little 2-frame animations of this awesome little skier dude. And then you can see here's this create an animation of snowman idle and snowman left and snowman right. And those are all being attached to the skier. So both the skier animations and the snowman animations are all being attached to that one skier sprite. And then it's a fairly simple case of when there's a collision between the skier and a separate snowman sprite, the player then changes his animation over to the snowman look. So it's almost like a skin. You can think of it that way. So I thought that was super cool, and it's a very cute game, so I recommend you check that out. That is Snowy Slopes by Eigenjoy, and that is my MakeCode Arcade game pick of the week. All right, so let's see. We've got some time now to dive into a couple variations on the project build for the week. So the project build this week is a animation controller, or rather a NeoPixel controller. It can be used for color and for animation. And I'm going to set up, I've got a couple of PyGamers here, and I'm using, in one case, MakeCode Arcade, and in another case, CircuitPython, thanks to Brent at Adafruit, who whipped up a CircuitPython version of this. So let's go to, how about a little down shooter here. And you can see I've got this nice big long NeoPixel strip. And what I've done is I've plugged it into one of the 3-pin JST connectors on the bottom side of the PyGamer. So we have D3 exposed, pin D3, and pin D2. And you can also use, I think, 8 and 9 analog if you're doing analog stuff. But in this case, I'm using pin D3, and then I'm plugging in this 3-pin JST connector, which has power, ground, and the data. And then I actually built this right inside of MakeCode Arcade, and I'm going to turn it on. So I've wrapped it around here, and you'll see why in a second. So here on my boot up screen it says Adafruit NeoPixel Strip Control, and then it's indicating I should press A. And here it says pick the number of NeoPixels in your strip. Press A for the color picker and B for the animation. So those are two different screens that I have, A and B screens. And then you can press the select button to get back to those settings. So it starts off with the settings, and I have it going all white on the pixels. And you'll see here I've lit up the NeoPixel strip, and I've also lit up the onboard NeoPixels, the little set of 5 that are built right onto the board. You can see them there. And this is pretty cool. Now I can drive this little cursor around using the thumbstick. And if I have a strip with a greater or fewer number of NeoPixels on them, I can set them just by hovering over, or I can go to the tens place there and jump back up to 30. And then everything you do from that point on will use that number of pixels. So we'll explore that later in a little more detail. But right now I'm going with the 30, which is how many I have on the strip. And so these are the two screens. There's the animation screen, and there's the solid color picker screen. So on the solid color picker screen, now I've got a whole bunch of NeoPixel colors, and all I need to do is hover over with my cursor, and I'll switch. Anytime I hit a color with the cursor, I'll switch to that color that's underneath the cursor. And so I'll run through them all here. And one of the reasons I wrapped this around here is that the PyGamer has an acrylic case that you can buy, or you can laser cut your own. I laser cut my own using, or just the top plate actually, using a diffuse white, sort of milky acrylic, which looks really great when it's side lit with these NeoPixels, and also underlit for the ones on the board there. So here I've just set up one black swatch that I can hover over to essentially turn it off. And then I can go, let's go lavender, or cyan, or super magenta, or it's light purpley blue. This brown actually shows up as tan-ish, or an off-white and white. And the cursor moves fast enough that you can actually sort of create little blinking effects. And then if I hit B, I'm going to switch over to the animations. And here you can see I've got these 6 stock animations that come in MakeCode Arcade that you can use on your NeoPixels. It's the same set that's in MakeCode for Circuit Playground Express or MakeCode Maker for other boards. And now if I hover over one of these, I'm going to essentially start looping that animation. So here I've got the rainbow animation running. Here's a little chase. Here's this sparkle. Here's a color wipe from blue to off to blue to off. This one's a theater chase, which it's kind of hard to see what it's doing with the strip wrapped around like this, but kind of like what you see around a theater marquee. And here's Comet. This one's cool. This one has a sort of ease in and ease out speed animation. So it's going in one direction, and now it's going to stop, and then it's going to start spinning that magenta in the opposite direction, leaving behind the blue. And anytime I hover off, I stop the animation. So I can turn on, let's say, a couple with that sparkle. I say that, there we go. And then when I get the cursor off of the animation, it stops in place wherever it was. So let's go now. I'm going to turn them off just by hovering over black. And now I'll go to the color picker and let's do, how about 10? Or how about 12? There we go. So now when I go to the color picker, you'll see only these first 12 NeoPixels on the strip are lit. I've got all of the onboard NeoPixels. I decided to not get fussy with it. So that number only refers to this JST plugged strip that's in D3. You could also set this up to run a second strip. I'm not sure if this will want to power both strips as far as current draw, but I think it probably would. I know that I had it running using Kattni's PyPortal script, which worked the same way. You had a dual strips that you could run at once. So I think this should be able to handle it. But yeah, you can see now everything I do from solid color picking to animation is only going to happen on those 12 pixels of that strip. So now I can jump back out and let's go back up to 30. And I'll leave that at the proper number. So now let's have a look actually at how this all works. So you've seen the demo. Jump back into MakeCode. I'm going to switch over to this sketch, which is in MakeCode Arcade. And let that reload. I'm going to run through how I've broken this down. So it's not super sophisticated, but it does have a lot of parts. And so when you have code that has a lot of parts, it's really helpful to create a bunch of functions. So you'll see in my onStart block, the first thing I'm doing is this onStart. And I'm going to create a background image that has this little, just an icon or a graphic I made of a NeoPixel strip just to look cute. And then it pops up my splash that says Adafruit NeoPixel strip control. And I'm using the splash element for that. And then I'm using these show long text to give the instructions of how to use it. Then I call the pixel counter setup. So that's a function that I have set up right here. And what this does is it creates a counter using the 7-segment display extension. So you'll see I have here 7seg. This is the 7-segment display extension, and it has both a counter and a digit. So I'm using the counter type, which is very easy to work with. Then I'm setting its color to green, and I'm setting the initial value to 30. Now jumping back to our onStart block, then I set the background image to just totally black, so I'm getting rid of that little icon I had on there. And then I'm setting this page variable to 0, and then I'm calling the page setup function, which in this case I've set up the function to have an argument. So if you look at when you create functions, you can create a function. So this is my function. And you can say it's going to accept arguments such as some text, a Boolean, true or false, or in this case, a number. And now when I have I'm going to cancel that. When I have a function that's been set up to have one of those arguments, I get this little pop-up, which would initially say 0. But I'm using this variable page, I wanted to set it up and I'm going to be using it later. So let's see what that function does. If I head over to page setup, this is a function that calls 3 other functions depending on the input argument. And the reason I did this is just to keep from having one big long page setup function that has too much in it to be, it gets kind of unruly. So if, in this case, the number that's being fed to it when I call the function is a 0, then I'm going to call this settings page setup. And that's this function I have sitting right here. This is set up initially to destroy any sprites. So when I switch between pages, and by pages I mean my, I'll run it right here actually. I have the counter page to show how many NeoPixels I'm using, or that animation page, or that color picker page. All of these have sprites on them. So the counter has the counter element, but then I've made sprites for those triangles. And so when I switch pages, I want to delete or blow away or destroy the existing sprites and then build a new set of the ones that I want on that page. So you can see in this case, when we go from something to this settings page, sorry, lost my mind there, I'm going to delete any swatches, which are what I'm calling those little color blocks, and I'm going to delete any anim icons using these 4-element value in an array list. And I'll show you those arrays in a second. So I delete any existing sprites with this destroy block, and then I set my counter display color to green. And the reason is I'm hiding it on the other pages by turning it to black, and it's on a black background, and it's the lowest order. It displays first, and the other things display on top of it. So when I come back to this page, I need to turn it back on by making those green again. And then I call my arrow setup. So let's pop over to arrow setup. This is where I'm making these up-down arrows for the tens place and the ones place that you see over here. And the array that I'm creating, this set arrow list to array of, and that contains all of those sprites that I've made, that's how I'm able to then go through and delete the whole list of them easily with simpler code that iterates through the list. So that's in here. If you look in arrays, you've got arrays that can be arrays of sprites, arrays of numbers, arrays of text. So once that arrow setup is done, we return back again to the onStart block. And in here, we are, let's see, then setting the bright strip variable that I created to 60. So that's how bright I'm going to have the NeoPixel strip be out of a possible 0 to 255. And I'm setting the onboard LEDs to 10. So I want those dimmer since you're kind of looking right at them. And then I call strip setup with my counter count. So that is a convenient little part of this 7seg is down here in the counter section. I have my counter count. So that means whatever number I've got that set to, in this case it's 30, is going to be the argument to calling this other function. So let's head over to strip setup. So strip setup creates a strip of WS2812, which is the NeoPixels, set on pin D3. So you can have it on any pin that's available here by adding the proper extensions, and this will be in the guide, with number of pixels. Well, that number is that counter. So we grabbed from what right now is listed as 30, or on my demo before 12, and then that gets dropped into this set strip. So it creates the NeoPixel strip with the proper number. And then I am setting the strip to not be buffered, and that means it won't wait for changes. Any change I send it to a pixel, it'll just happen immediately. And then if you're used to Arduino, this is sort of like not having to use show strip, or in CircuitPython the equivalent. Then I'm setting the strip brightness to whatever that variable was, so you can change it in your start block. I didn't expose that as a control because it eats up a lot of memory to go changing that too much. And then I'm setting all the strip pixels to white. Then I'm setting the brightness to whatever that variable I had in the setup for the onboard strip, and then I'm setting all the onboard pixels to white. Shoo! So if you're wondering where I'm getting these from, if you look in the light section, normally you just have this top section, but here you can see I have this ... more, and that's because I added the NeoPixel extension over here in extensions. It's not going to show up now because I have it already loaded. But when I click on light, it actually drops down this second section, and this is where we can do these NeoPixels or even dot stars, and all of the related blocks for using those live right there. So once I'm done setting up my strip, let's go back to the setup. And the last thing I do in this setup is call the cursor setup. And the cursor setup just creates a sprite that is this little crosshair with a red center. I made that of type player just because it's convenient. And then I'm using the move cursor with buttons block, so that's how my thumbstick can control that cursor around. I'm setting the Z depth to 2, so that's further on top of things if you're thinking of layers, with 0 being sort of the screen layer, so that it'll appear on top of my swatches. And I'm having this stay in screen turned on so I don't lose my crosshairs off the edge. At that point, there are a couple things we can do. We can use buttons to switch between the different screens. And if we, let's say, press A and call the swatch setup, this is going to call my page setup for page 1. So page setup with an argument of 1 says call the color page setup. And the color page setup, this was a big one actually. Let's come on over here. Color page setup, so it destroys any existing sprites, then it sets the counter to black so we don't see it, sets the strip length to the number of pixels, and then we're calling these 3 functions: swatch sprites, swatch positions, and swatch depth. So swatch sprites, here's where I'm just manually, one at a time, creating all of those different color swatches. So you see here I've got all these, I think 15 of these. So I create them, and what I did was I decided to give the sprite kind, normally you'll see player, food, enemy, and power up or something, projectile. But you can add new kinds. So what I did is I just simply made a new kind of sprite name, the kind name, that represents red, orange, yellow, and so on. And the reason I'm doing that, once these are all set up, and there you can see I make an array so it's easy to blow them all away later, is how the thing actually works, is that I'm using the onSprite of kind player overlaps other sprite of kind and then fill in the blank. So this one's set to orange, but you could set that to red. So what happens is whenever the player sprite overlaps another sprite, it checks to see what kind is it, and if it's of kind, in this case orange, then I'll set all the pixels on the onboard to orange, and I'll set all the pixels on the strip to orange. So that's it. I just do this a whole bunch of times in order to get that overlap to set the pixel color. And animation looks pretty much the same. I have a similar setup page that creates the animation icons that I put on the screen, which you see there. And when I hover over, let's say, one of kind theater chase, then I show animation of that kind. So this is just built into MakeCode Arcade. So of kind theater chase, and I set the strip to that as well. And then I'm setting a little pause manually in here so that it doesn't run too fast. And I've tuned those to be different speeds in some cases. And so the way this works is the whole time I'm overlapping, we're just going to keep playing one frame, pausing, 20 milliseconds, play a frame, pausing. And so let me go back to the overhead, and you can see that in action because I can't show that in the simulator. Let's do this one right here. So you can see as I'm hovering, this is a good example one here. As I'm hovering, it's just playing one frame, and then it's looking up and going, am I still overlapping or colliding with that? It is, so it plays it again. And that's how I got it to work without needing to click a button, and when I move the cursor off, it stops. So I thought that was a pretty elegant way to do that and kind of a nice control. So I think that pretty much covers the code. So you can see there's 6 of those for the animation. Here's 15, I think, of these. Yeah, 15 of these for the colors. And it's essentially using the same trick everywhere, even for these up and down arrows. When I go to hover over these, that's just saying if there's an overlap, then we're going to increment by 10, or we're going to increment by 1, or decrement, and then it has a little like 400 millisecond pause or something like that, so it doesn't move too quickly. So I thought that was sort of a nice, efficient, elegant way to reuse the same interface mechanism everywhere, so that the user gets used to that, and they're just, wherever I put the cursor, it does something. There's no clicking necessary. Buttons are just for switching pages. And then lastly, I had asked, actually, I think PT had asked, hey, Brent, or Lady Ada had asked Brent Rubel at Adafruit if he could do a version that would work in Circuit Python. And so let's see, do I have, oh, I don't have my Atom code up. Let's take a look at the thing first. So I can turn off that green screen effect. Hold on. Stop trying to green screen. Okay. So here is a second PyGamer that is running Circuit Python, and you can see here I've got my NeoPixel strip plugged into it. I'll wrap that around it a bit so you can see it. And this is using the cursor library to move this cursor around the screen with your thumbstick. And then this one, Brent did a little differently, which is we are going to press a button, and it doesn't have the other pages. This one, he did it very quickly, and he wasn't trying to replicate all the fancy things I kept adding to mine. I kept feature creeping it. But the simple version of it works great here. And it also makes use of some of the existing code that Kattni had created for her PyBadge version of this type of a NeoPixel strip color picker. And I just wanted to show 2 things in the code that I thought were pretty cool. So let me bring up Moo, and I need to add, I'm going to add a Moo to this. So sorry while I add a screen capture element. 1 second. And window, select window, Moo editor, almost there. OK. It's creating it. And there it is. So let me go to that Moo session so I can see it. Here in the mouse cursor code, so this is part of the cursor library, we're creating a cursor instance called mouse cursor. And the arguments are display group, splash, cursor speed, and scale. So these are really cool. If I change cursor speed, I can make it super slow. Let's go to 2 here. And I'm also going to make it really huge. So I'm going to scale the cursor. And let's plug my PyGamer in so that I can update that. And save the code. And now, if we hide that Moo session, you can see I've now got this really slow, humongous cursor, which is fun. I haven't tested the limits of this thing, but I imagine we should. So let's make this huge, huge, huge. How about 5? And I'll make it fast again. I'll make it real fast. So huge and fast. Yeah. And now I've got, oh, you can see, ooh, it's doing a little bit of the trails. Do you remember when Windows, like Windows 95 or something, Windows 3 had that trails thing in it so you could follow the cursor around? We're sort of accidentally getting that ghosting trailing effect. But it still works. I can even still get the pointer everywhere I need to. So thanks to Brent for creating the Circuit Python version, and he wrote up some notes, so that's going to appear in the guide as well. And that about does it for today. So I will throw in just one more reminder of our coupon code for the day if you want to go and get some cool stuff. Maybe some NeoPixel strips with JST connectors on them like these are really cool. maybe some slide pots. You can get 10% off. Just use the coupon code CONTROLLER when you go to the store, and it will do all of the math for you. So I will say goodbye now, and I'm going to hang out in the Discord chat a little bit. So if you got questions and comments and thoughts, please stop on by. Oh, shout out to Toddbot, who just joined us a little while ago in the Discord chat, who was making fun of my green screen bleed through. Let's put some green screen mess on here. How about there? Look, green screen is. Oh, why is it? That cursor is white. I don't know why it thinks that it's green. But now we can see through. Well, I got nothing to see through on there. So here we go. Let's turn that guy's green screen on. And now we can see through that little hole. How about that? Fun with green screens. So, yeah, thanks for stopping by. And thank you, Andy Calloway. Thanks, Mr. Certainly. Thanks, C. Grover. Thank you, Yanni Turnin, Andy Lear over in YouTube chat, and anyone else for stopping by. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Bye-bye.